First of all, just imagine yourself that you had invested 10,000 rupees worth of money on Bitcoin back in 2010. So, my dear friends, if you took that decision before, you won't be sitting there listening to my speech on Bitcoin and blockchains. And if I took that decision, I would be never standing here explaining about this. So, here's how the figures look like right now. So, if you had invested that kind of amount there, you would be a billionaire and you will have a net asset of 24 billion, undoubtedly, because right now Bitcoin is at its worst. So to understand blockchains and Bitcoin and how it goes in our financial networks, first we have to understand how this current financial system is, architecture is right now. So currently we have a centralized financial system. As you can see here in this figure, smaller institutes, financial banks actually do perform their transactions, and those transactions are transferred into a centralized place. So you do a transaction in a bank, and those transactions are transferred into a centralized place. For example, just take Visa. So if you, currently Visa actually perform 200,000 transactions per second. And if you go into an ATM and do a Visa transaction, and if another person go into some kind of do a Visa transaction, and those two transactions go into a centralized place. So that is the current architecture we have right now. So why do we actually need this kind of a centralized architecture? Thing is, it's a fundamental human need, trust. So when it comes to money, trust is really important. You need some kind of assurance on the money, on the lifelong money that you are investing, and also you need some kind of a place where you can take legal actions if these promises are broken. So is that the best solution that we can give for this financial industry? Actually, it's not. In 2007, there was a huge financial meltdown, and big banks like Lehman Brothers, JP Morgan in US actually did a fraudulent information on subprime mortgage market, and those banks got greedy, and because of that, there was a huge financial crisis. And third world countries like Sri Lanka actually got affected by this, and many people lost their jobs. So we can see that there are several issues with this. As programmers also, we know that in a centralized architecture, there is always a central point of failure. So what we can actually do is introduce a distributed financial system. The concept that we are actually describing here is a distributed ledger of transactions. So in this one, in this concept, there's a centralized ledger, and that ledger is distributed among nodes of a network, and in that network, everybody can do transactions. So for example, a person go into a node and do a transaction, and the ledger is get updated. So that ledger is propagated to other nodes, and they keep the flow of transaction like that. So theoretically, we can actually say that, but it's really hard to implement. This introduces another set of problems. One of the major problem is this double spending problem. To understand this one, let's say I have $100 in my account, and I write two checks for exact amount, for $100, and I send two people to two nodes and say them to execute that exact transaction at the very same time. So in a distributed system, there's a risk that both of the transactions could get executed at the very same time without the validation. But in a centralized one, if you think about Visa transactions, always the first transaction executes first. But in distributed system, we cannot guarantee that. So this has been the issue. This has been the problem that everyone in the world tried to find answers. They have been trying in decades with the existing technologies. until 2009. A mysterious person called Satoshi Nakamoto introduced a white paper to a very famous crypto forum saying that he has cracked this. So he said a decentralized peer-to-peer financial system can bring a solution for this double spending problem. That was the beginning of this blockchain system and Bitcoin. So by means of a peer-to-peer network, we share a ledger of transaction publicly throughout the nodes. And anyone can actually inspect these transactions, the ledger, and do any changes to it, but within limitations. So the blockchain technology lies on 3 pillars. The one that I told was the peer-to-peer networks, which is done with P2P protocols. And the other one is game theory application with consensus algorithm. Previously, I mentioned that the trust is assured through banks. Now, in distributed financial system, the trust is assured by algorithms and mathematical derivations. So what they actually do is they validate. They decide what data should go into these blocks. They decide what should be the amount or dividend that go into a person who finds hashes. So that is actually the algorithm which is written here as consensus algorithm. So other part is the cryptography. If you think about if you need some kind of privacy or transparency, we actually need to have hash cryptographic algorithms and generate public keys and private keys and do the sharing. So these are the 3 pillars. So with these pillars, they have introduced a chain system, a linked list, where they can actually point out their parent block with hashes. And each block may contain a single or multiple transactions, and those transactions will be validated with the consensus algorithms. And we have a hash. That hash is generated, and it will point out to the previous block. So we have a series of blocks, and currently we have a 40 GB transaction block set in Bitcoin. So to summarize what I said, we have a blockchain which is generated with consensus algorithms and everything. So it is a distributed ledger which is distributed with P2P network, P2P protocols throughout the nodes. So how the blocks are generated, how the hashes are generated, what's the fuzzy thing about mining, and everything will be explained by Priyath. And Priyath, over to you.
So the important thing that you have to realize when we talk about the blockchain, the Bitcoin technology, is that the individual components of this Bitcoin technology is not new. See, cryptography and peer-to-peer networking, all of this has existed for a long time. But what's truly brilliant is how that unknown person put all this together to come up with a solution for a distributed financial system. So to understand Bitcoin, we need to understand what happens at the very core of Bitcoin. And as like Sandaruwan mentioned, at the core of Bitcoin is something that's called the consensus algorithm. Now the consensus algorithm is nothing but a way for a distributed system to verify the transactions that takes place. So this is the replacement for a bank in a centralized financial system. And how this is implemented in Bitcoin is with the use of cryptography. So to better understand this, we need to deviate a bit from the topic and go through a very small cryptography lesson. So at the center of the consensus algorithm lies the SHA-256 hashing algorithm. So the SHA-256 hashing algorithm is very simple to understand. If you give it an input, it will always produce a 256-bit long output. So that's all there is to it. And 256 bits means the total possible range of a SHA output is between 0 and 2 to the power of 256. So that's a really big number. And if you look at the slides, you can see 3 examples of the SHA algorithm, where we use the text hello to find its corresponding SHA-256 hash. So the key point to notice here is, for the same input, you will always get the same output. But if the input changes by even a small amount, there will be a very big change in the output. So how does the consensus algorithm use these concepts within its algorithm? So to understand that, let's simplify SHA-256. So let's assume for a second that the output range is between 0 and 1000. So what this means is, if you give our imaginary SHA-256 any input, the output will be a number between 0 and 1000. So for example, in this case, if you give the string hello, the output will be a number which is 565. So that's easy enough to understand. So now, what if I extend a challenge for you? I give you the string hello, but now I tell you, I want an output in a specific range. So first, I will tell you the range should be between 0 and 1000. So that's easy, right? So all you have to do is send it. So all you have to do is just one iteration, and the output is guaranteed to be between 0 and 1000 by definition. But the thing is, I can increase the difficulty. Now I can tell you I want an output in the range of 0 to 500. Now looking at this problem, that's impossible, because by definition, SHA-256 gives the same output for the same input. So the only option you have is to bend the rules. How you can do this is you keep the string hello the way it is, but you append a variable to it. This will change the overall input. It will keep the input string that I gave you constant, but the overall input will change. And using that mechanism, you can generate different hashes. So something like this. So here's the example. So what you're going to do first, you're going to add the number 1 to the end of the string that I gave you. And this time the output is 635. But my target range is 0 to 500. So what can you do? The only thing you can do is try again with a different input. So you do hello 2. So similarly, you get it, right? You can run multiple iterations until the output matches my target range. And also, if I keep reducing the output, the difficulty level on average is going to increase. Smaller the output, the more iterations on average that you might have to take to find the answer. Now it's a given. Sometimes if you get lucky, you might get a number in the first iteration as well. So this is what's at the center of the consensus algorithm, and in turn at the core of Bitcoin. So to understand how Bitcoin uses this to validate transactions, let's take a look at an example. So again, we have to simplify all this to understand this. So here's a Bitcoin network with 4 nodes, A, B, C, and D. 3 blocks. So each has a distributed blockchain recording all the transactions that has happened in this Bitcoin network. So let's say a person called Alice wants to send 5 Bitcoins to Bob. So what does Alice do? So what she does is really simple. She projects this transaction into the Bitcoin network. Now Alice's transaction will be in the network, and what happens next is this transaction will get propagated to all the nodes in the Bitcoin network. So in this case, A, B, C, and D. Now this propagation happens because now the nodes will independently validate this transaction. So the validation is done through the consensus algorithm, and the consensus algorithm that Bitcoin has implemented is called the proof of work. So proof of work is nothing but the way Bitcoin validates transactions. So this validation happens in 2 steps. Step 1, so this happens independently at each node. So the first step is, once the transaction information is received, the node will run a set of validation rules that's defined by the Bitcoin network to see if this transaction is valid. Now that's the easy part. And these rules are defined in the Bitcoin network, and these rules contains things like does Alice have enough bitcoins in her account to do the transaction? Now, once this validation is complete, still this block cannot be added to the blockchain until step 2 is completed. Now, step 2 is where the interesting bits happen. See, step 2 is a race between the nodes. And this race is to find a hash. And this challenge is very similar to the challenge I explained previously of you finding a range that I specified using a string hello. The only difference is this time the total range is between 0 and 2 to the power of 256. And the target range is not specified by me, but by the Bitcoin network. So the Bitcoin network has a specified target range, and the nodes need to use an input to generate an output that matches this target range. And the beautiful thing about SHA-256 is the only way to do this is to brute force it. There's no shortcuts. So each node will have to do this work to do the validation. So what happens is the input this time will be the transactional details. So this is similar to the hello string that I showed you all previously. So a node cannot change this. What the node can change is the variable that they append to it. And this is called a nonce. So the nodes will keep iterating different combinations of these nonce until the output matches the target range that's specified by the Bitcoin network. This takes serious processing power. Now, eventually, one of the nodes is going to win this race. One node is going to find a hash that matches all the criteria that's specified. In this case, let's assume node A is the winner. But finding the hash is not enough to win this race. So what node A needs to do is, they need to propagate this block to the other nodes as well. So node A will propagate a block with the newly found hash, the transaction, the nonce that it used, and all the transaction details. And this will also have the hash of the previous block, which was found in a similar way, to all the other nodes. And what these nodes will do is they will stop their processing, they will check this newly received block. And so once you have the input and the output, it's very simple to validate it. It's just one iteration. So the other nodes will verify it, and then they'll see that A has been telling the truth, and they will add this to their blockchain. So on a very high level, this is how the Bitcoin network validates transactions. And you might have heard things called mining and that sort of thing, right? So the process of nodes continuously looking for these hashes is what's known as Bitcoin mining. So why would a bunch of nodes spend so much CPU power processing hashes to validate other people's transactions? Why would they do that? And the answer is simple. Bitcoin has a reward mechanism. So whenever a node finds a hash and that block gets validated and it gets added to the individual blockchains, the node will be rewarded with 12.5 Bitcoins. Now that's the whole incentive behind this, and you can see how brilliant this idea is. It's a network that solves the double spending problem as well as a network that self-sustains. So it's a very valid question. Does the proof of work actually work? So it's a bit hard to understand these parts, but let me simplify it. If a node decides to validate a transaction, that means that node believes that transaction is valid, right? Otherwise, it would not spend its processing power trying to validate it. So basically, CPU power is an implicit vote that a node can cast. CPU power corresponds to a vote in the Bitcoin network. And the golden rule in the Bitcoin network is the longest blockchain there is will always be the valid one. So because, think of it, the longest blockchain will have the most number of validated blocks. So the most number of validated blocks means it has the most CPU power invested on it, because the only way to add a block to the blockchain is to find the hash through brute forcing. So the golden rule is the longest blockchain is the valid one. So this concept works unless The only way to compromise this is if someone holds a node, a particular node holds more than 50% of the whole processing power of the Bitcoin network. So what this would mean is they would, theoretically, they would be able to find new hashes on average faster than the rest of the network. And eventually they can create a blockchain that's larger than whatever exists in the other nodes. And going back to the golden rule of Bitcoin, which is the valid blockchain is always the longest one, this can effectively be compromised. And the other thing is, but if you look at the hashing power, which we'll take a look at next, this is, at this point in time, the longer the chain grows, the harder it gets for a single node to own more than 51% of the hashing power. And the other thing is, the way blocks are linked. The blocks are linked by hash. So, say one person goes and changes the second block in the Bitcoin blockchain, right? So they change the transaction value, maybe say it says 50, so they change it to 100. So now this block has been tampered with. But what this means is the hash of that block will have to be recalculated. So the second block is now invalid unless the node that tampered with the block will spend processing power to recalculate this hash. But that's not enough. The next block's hash depends on the third block's hash depends on the second block's hash. So what this means is it will also have to recalculate the third block, the fourth block. Now the Bitcoin network's blockchain is more than 5 lakhs. So that's 500,000 blocks that a node needs to alter, and they need to do this within 10 minutes. Because on average it takes 10 minutes to find the hash for a new block in the Bitcoin network. So at this point in time, it's a computational it's impractical computationally to modify the blockchain. So just to put this into context, the total hash rate generation power of the Bitcoin network is 15 trillion hashes per second. And like I said, it still takes 10 minutes on average to find a valid hash. So that's a total of 9,000 trillion hashes on average to find a valid hash. So that's the sort of processing power that's behind the Bitcoin network right now. So I'm sure all of us would love to start mining, right, to find Bitcoins. But the thing is, mining in 2018 has turned into a specialized industry. Solar mining is going to cost you more money, spending more money paying electricity bills than on actual profit. So the sad truth is, we can't really start mining now. That ship has sailed. So just to conclude, so that's how Bitcoin, that's basically how it works. So just to conclude here, the discussion that we really want to address is blockchains and Bitcoins, because blockchains is a buzzword that gets thrown around a lot. People say that blockchain is transforming this, blockchain is transforming that. But what you need to understand is Bitcoin solved a very big problem, and the problem was how can we implement a financial system without a centralized party, without a third party that we can trust. So what Bitcoin basically did was they eliminated the banks and replaced this with technology. So we basically handed over trust from third parties to an algorithm. So blockchains is only a part of this solution. The true genius and the true brilliance lies in the proof of work, the consensus algorithm in Bitcoin. So blockchains without Bitcoins, an interesting analogy would be a sailboat. See, a sailboat is a revolutionary idea, and it has served humans in many valuable ways, I'm pretty sure. And the sailboat has lots of components to it. One of the main components being the sail. Now imagine a sailboat without a sail. It might have a few users, but it's still not revolutionary. So Bitcoins, so if you take Bitcoins out of blockchains, it's something like this. It's like a sailboat without a sail. So, but can we do that? Can we separate blockchain from Bitcoin? Yes, we can, and it has been done. So these are all major banking institutions in this world who has invested lots of money on blockchain technologies to improve their financial systems. But it's ironic, isn't it? Because Satoshi Nakamoto, he or she or them came up with a system to replace the current financial model. And the same people are using that technology to improve themselves. So when people say they are using blockchains, the main question to ask is, what is the consensus mechanism that they are using? And I guarantee you, these people are not using a proof of work. A proof of work takes the trust from us and it places in an algorithm. But these people can't afford that. So the blockchain without proof of work will work, and it might have a lot of benefits. But this replicates the current financial system that we already have. There's nothing new in that. So to sum this up, my personal opinion is the truly revolutionary idea is not blockchain, but how that was used along with the proof of work to invent a new cryptocurrency that's called Bitcoin. Thank you. That's it.